Okay, this is Mr. Bloom. This is Chapter 4 review. Now, keep in mind when we're looking at this type of diagram, there are a lot of people that are mystified in how I can get numbers out of it. But the markings are important. They're significant because these markings here mean that this triangle WXY is an equilateral, equiangular triangle. All the three sides are the same and all three angles are the same. You've got to keep in mind that there are just as many angles congruent as triangles there are sides. So because of that tidbit of information, I know that each one of these angles is congruent. Because each one of them are congruent, this column X, there's three of them, they go in the 180, X is equal to 60. So each of these is 60 degrees. Now, when we're looking at this next triangle, which is isosceles, I have a linear pair that'll help me understand why my vertex angle will be 120 degrees. This is 60 from our previous problem, or part of the problem, and this angle right here is going to be 180 minus that 60, which is 120 degrees. So that's 120. Now this green triangle has two base angles that are congruent because it is isosceles. So this is an isosceles triangle, and I already know a 120 degrees of it. So I know that, and I know that two of them are the same, and I can find out that my angles are 30 degrees apiece. So now I can take away my little markings I have here, and I can write in my angles so it's clear about what I have and everything. Let's take those away too. So I got my 60s, and I've got 120, and I've got 30, and I've got 30. So now when I'm looking at my angles, and let's get a pointer here. Let's make that a little thicker. There we go. Oh, I'm a little too thick there. All right. So now, as I'm going through here, I've got YXW. YXW. X is the vertex here of this angle, and so that is 60 degrees. XYZ. XYZ has a Y as its middle value, so that's the vertex, and so it's 120 degrees. Z. Z is the only letter out here. I could say YZX or WZX or XZY or XZW, but still angle Z, and it is 30 degrees. WYX. WYX is 60 degrees. YXZ, YXZ is 30 degrees. ZXW, ZXW is 60 plus 30, so that makes it 90 degrees. And that is equal to my 60 degree angle plus my 30 degree angle. And then finally, I've got angle W out here, and that is a 60 degree angle. So that's me finding the angle measures in problems 1 through 7 without any numbers to start. Now in 7 and 8, what is the measure of angle D and what is the value of X? This is significant because I've got to know a couple things. First, these markings, and let me grab my little pointer from the previous problem, that'll help us out. I got my little pointer, and these markings here, so I'm looking this over. Let's get this up a little higher. Sorry, my video's in the way, my framing. So I'm looking at these two congruent sides, And because I have congruent sides, two of them, that's isosceles. Isosceles triangles have two congruent sides, and consequently, across from those sides, two congruent angles. So I've got to keep that in mind. So they're asking me to find angle D, and angle D and angle F. Angle D here and angle F here are going to be the same angle because they are base angles of an isosceles triangle, and this is the base side, and these are the two legs, and this is the vertex angle. Now, with that information provided, I know that my isosceles triangle has a vertex of 48, and I have two values, let's call them y, for my two angles that are angle D and angle F. So once I know those, I know I can subtract 48, and so now I have 2y is equal to 132. And divide by 2, so y is 66. Well, I know D and F, angles D and F here, are 66 degrees. I'm using triangle sum theorem and the idea of isosceles triangle, base angles, to help me find it. So now that's my angle D. Now for X, I told you that these two are equal. Well, if they're equal, because they're the same, they're congruent, I can set them equal algebraically. 5x minus 10 is equal to 3x minus 4. Now, why am I doing it just on those twos? Because it's an isosceles triangle, those sides are equal. This base here is given to you, but it's extra information to keep you from finding the right answer. It's junk. So now I solved this other relationship. I have 2x minus 10 is equal to negative 4. 2x is equal to 6, and x is 3. So my x is 3, and those are the values I'd have to make this all work. Now, in this next question, I'm asked how many right angles can an isosceles triangle have? Well, any triangle can only have one right angle or one obtuse angle. And the reason being is after you get that one right angle, there's only 90 degrees left. After you get over obtuse, over 90 degrees, it's obtuse. And once you get that obtuse, it's just less than 90 degrees, the share between the other two angles. So as soon as I get to right, I only have 90 left, and as it gets bigger, it's even less than that. I cannot have any more. So we can only have one right angle. Since the other two remaining angles, I should not say remaining, but other two angles, sum to be 90 degrees. In 10 through 15, we're going to decide whether it is possible to prove the triangles are congruent. So we're going to be looking at triangle congruence theorems and postulates. These are the ones I'm considering. And these are the only ones we have. So we're considering triangle congruent statements, or postulates, theorems. Well, here I've got this is reflexive, and I've got a leg, and it's a right triangle. So this one is by HL congruence. They are, I suppose I should say yes, because are they congruent? Yes. How do you know? Because of HL congruence. And 11, are they congruent? Yes. Okay, how do I know? I've got side angle, and I've got this marking to this marking. I got this marking, this marking, my two angles in my side. Now, I have two angles and a side in here. I have a choice down to angle, side, angle, 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 side. The difference, angle, side, angle has the two angles attached to the side that's congruent. So I've got angle, side, angle, congruence. And 12. I'm looking at it's a right triangle. Looks, I've got to go for right triangle. Could it be HL? But I don't know anything about the hypotenuse, the things across from the right angle. So I've got to look at this and go, all right, I got those other two angles. I got these two. And these two right angles and a side. So I got angle, angle, side. That's what I'm looking at. So yes, by angle, angle, side congruence. Now I'm going to bring these bad boys along to my next one, and actually I'm going to bring my pointer along too. So I'm going to bring these to my next page. Maybe. Okay, now that I got those back in there, I'm looking at problem 13, okay? And I've got these mean that these are right, not right angles, that these are parallel to this. And this marking means that these two are parallel. So now I've got to consider this transversal. This transversal in this line and this line talks about those angles being congruent. If I'm talking about this green transversal, I mean, I know I'm doubling the transversal, but I think it's good to see these other angles in there. And I know that since that's the same transversal, that's congruent to itself. So I've got angle side angle here on this. So I'm going to be looking at angle side angle. So yes, angle side angle for my answer. In 14, I'm given that this is reflexive, and they marked it for congruence. I've got a right triangle. I don't know for sure whether these hypotenuses are the same. So there's not enough information to determine whether that's congruent or not. In 15, at first glance, it doesn't look like much, but I've got a bow tie look. So these two angles are congruent to each other. I got two angles on the side, and those two angles aren't both attached to the same side. So this is going to be congruent to each other, but it's going to be by angle, side congruence. In 16, what kind of triangles are the triangles in number 12? In number 12, if I arrow back and look at problem number 12, they want me to come up with a classification. Now you can classify by sides, isosceles, equilateral. Isosceles is two sides equal, equilateral has three sides equal, and scalene, which have no sides equal. Right now I only have one side on one triangle congruent to the other in problem 12. And so it's looking like it's scalene. There isn't another marking to tell me if the sides are congruent. And I have the largest angle in the triangle, and I know that's 90 degrees. Triangles are classified by sides and angles, and the number of sides that are congruent, but then the angles that are in there, it's classified by its largest angle. In this case, its largest angle is 90 degrees. So if I go back from 12, I've got a scalene right triangle. In 17 to 19, this was really tough for some folks, but if you look at it, you're thinking, well, triangle ABC has angles with the following measures. So if I just sketch out a triangle, let's call this A, B, C, and A was X, B was 2X, and C is 6X plus 90. If I gave you that picture, everybody would be happy as larks because they're like, well, I got triangle sum theorem. X plus 2X plus 6X plus 90 equal 180. So now I've got 9X plus 90 equal 180, and 9X is equal to 90, and X is equal to 10. I can plug that back in and find out that since A is equal to X, A is 10 degrees. Since B is equal to 2X, 2 times 10 is 20 degrees. And since C is equal to 6X plus 90, 6 times 10 plus 90 is 150 degrees. Now, keep in mind, if you've got questions on something, just kind of run through it again, slow it down. But the best study you can do for this is to make sure that the problems that you have difficulty with, you go back and you cover up your solutions, you try them again with a blank piece of paper, and you keep doing them until you get them right, and you're comfortable with getting them right. Now in 20, 21, and 22, I'm just using triangle sum theorem or exterior angle theorem, and these are all triangle sum theorem, and nope, I lied. 20 and 21 are kind of triangle sum theorem, and 22 is isosceles triangle. It's kind of sneaky. Base angles are congruent, and that means an isosceles triangle. But let's start at 20. In problem 20, I know that three angles added together will add up to 180 degrees. The danger of this is writing everything out. So I've got a 3x, a 2x, and a 3x, that's 8x. A 5 and a 15, that's 20, is equal to 180. Now I subtract my 20, 8x is equal to 160, so x is 20. They would like me to solve for x and then write the answer on the blank, so x is equal to 20. I'm going to make sure that I use some space, or better use my space. So I'm going to group this a little bit and shrink it down so it fits in my spot. Now, I could do 21 exactly the same way. 2x minus 65 plus 90 plus x minus 15 equals 180. Completely and totally. But I know stuff about triangles. I know in a right triangle, because it's a right triangle, the two acute angles make 90 degrees. So I could do it this way. So I've got 3x minus 180 is equal to 90, and 3x is equal to 270, and x is equal to 90. So x is 90. That is meaning that this is 65, because that's 90 minus 15. Excuse me, 75. Now, up here, if x is 90, that means this is 180 minus 165, which is 15. And that seems to make sense. Let's do that again. 90 minus 15 is equal to 75, and 180 minus 165 is 15. 15 and 75 is 90. Totally going to work. So I know that x is 90 here. Now, I'm finding x still, and I'm looking at an isosceles triangle. Base angles are congruent across from the sides that are congruent. So those two sides are congruent. 3x minus 10 is equal to 5x minus 20, and this base measurement is not necessary for helping us find the answer. Okay, because we're looking for a relationship to solve for x, and our relationship is about the two sides that are congruent. So I got negative 10 is equal to 2x minus 20, and I got 10 is equal to 2x, so x is 5. In 23, another triangle sum theorem. Okay, so again, all three angles of interior angle measures of the triangle are 180 degrees. I got to be careful about this because it's got some funky looking stuff up there. So I've got 9x minus 3 plus 10 times the quantity x plus 1. So now I got to combine like terms after I distribute here. So I got 7x, 10x, 9x, that's 26x. I got negative 3, positive 10 is 7, minus 9, which is negative 2, and that equals 180. So now I got 26x is equal to 182. Dividing by 26, I'm going to get 7. So my x is 7. I'm just going to double check. 182 divided by 26. Yep, we're all good. And we're supposed to just find x. So x is equal to 7. In 24 and 25, the relationship is about exterior angle angle theorem, where if I have a triangle that's numbered, let's call this 4, this 1, and that 2. Measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. That's the exterior angle theorem. It's something that we have as a review from chapter 3. And when I'm looking at 24, I've got 38 plus 7x plus 1 is equal to 10x plus 9. Well, that's 39 plus 7x is equal to 10x plus 9. I subtract 9 and I get 30 plus 7x is equal to 10x. I subtract 7, I get 30 equals 3x, so x is therefore 10. Let's check it. So if x was 10, that makes this 71, and 71 plus 38 would be 109. Well, 10 times 10 plus 9 is 109, so we've checked our work, so x is equal to 10. In 25, it's twisted, but it's still an exterior angle theorem problem. So I'm talking about 10 times x plus 3 is equal to 7x minus 1 plus 58. And I've got 10x plus 30 is equal to 7x plus 57. And I got 3x plus 30 is equal to 57, and 3x is equal to 27, and x is 9. So if x is 9, 9 times 7 is 63, minus 1 is 62, and 62 plus 58 gives me a 120, and 9 times 10 plus 30 is 120 as well, because this is 12. 9 plus 3 is 12 times 10. It's going to give me 120 as well. So I'm very confident to say that x is 9 here. So x is 9. And I'm going to bring that down a little bit and this down a little bit, so it's out of my way for this next problem. But those are the answers for 23, 24, and 25. In 26 and 27, you got to keep in mind, I am completely and totally using this congruence statement. And I'm supposed to find x. And I'm looking for x in the problem, and I find it right there. There's x, 4x minus 3. Okay, well that's kj. Kj is 4x minus 3. That's in the same position as AB. Well, AB is 9. So I know that since that's true, AB is equal to kj, and so therefore I can say this. Now I'm just doing this to make sure you realize order matters, and that's why I gave you the congruence statement. Now I'm going to find out that x is 3. So my x value is 3. Okay, now my next one is finding y, and my y value is right there. It's h, and h is in the same spot as c, and c is 113. So 113, or measure of angle C, is equal to measure of angle H. Let me slow that down a little bit so you see that. I got the measure of angle C is equal to the measure of angle H. So now I can say 113 by substitution equals 5y minus 12. I add 12 and I get 125 is equal to 5y. Dividing by 5, I know 25 is equal to y. Now we got some proofs to do. Okay, apparently I got to clean this up from the last time I did this. First thing we got to do, write down our given. So, step 1, segment WZ bisects angle XZY and angle XWY. That's my given. Okay? So that's my step 1. Step 2, let's talk about what I'm provided, and let's talk through what I know. Based on my given, I know that this angle, XZY, has been cut in half by the knife WZ. So WZ is cutting this in half. So this angle and this angle is congruent. Well, it is also cutting this part of the angle in half, so this angle and this angle are congruent. So I'm going to talk about that right away so I don't forget. So I know angle XZW is congruent to angle YZW. I also know for the same reason that angle XWZ is congruent to angle YWZ. And these are both, for both of these reasons, definition, angle bisector. Now, that was completely and totally able to be done because of my given. The next thing I'm going to look at is ZW is congruent to itself because of reflexive property. Now, I'm here to prove two triangles congruent, and I'm able to do that coming up next in my fourth step here. I know that my triangle WZX is congruent to my triangle WZY. Now remember, I have those 5 congruent statements. HL requires me to have right triangles. I do not have that, so I cannot use HL. I have only one side, so side, 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 and side, angle, side are right out the door. I have 2 angles and a side, so it's either angle, angle, side, or angle, side, angle, and these 2 angles are attached to the side that's congruent in each triangle, so it's got to be angle, side, angle. And that's our first proof here for the review. Okay, I'm just going to group these together. Make it smaller because I got a little rambunctious there, using up a lot of space. Now, in problem 29, again, first thing I got to do, write down my given. So I'm going to write down my given, step 1. AB, segment AB, we're going to write a little bit bigger and shrink it down there. AB is parallel to DC, and BE is congruent, segment BE, is congruent to segment CE because of given. I just rewrote what I was provided. Now I'm going to look at it. These are parallel, and because they're parallel, they give me alternate interiors. And I'm going to be lazy. I'm just going to use alternate interiors. Okay, so this one is congruent there, and this one's congruent there. And I'm going to look at this, proving these 2 triangles by angle, angle, side. Okay, just because of the parallel lines. So I know now that angle B is congruent to angle C. And for the same reason, I know angle A is congruent to angle D. And remember, I'm using alternate interior angles. These are my parallel lines. This is my transversal. That's my alternate interior angles there for A and D. And my alternate interior angles for B and C. That's why I'm ordering the way I am. Now we'll get rid of those, and we'll come back to our markings because of alternate interior angle theorem. Now, in 3, I have my 2 triangles congruent. Triangle ABE is congruent to triangle DCE because of angle, angle, side congruence. Now, there are 2 other ways. 2 other ways I am going to use. I could use to finish that out, but I won't use that. I'm just going to use this for angle, angle, side, and we'll be done. If you have questions about the angle, side, angle, or the other angle, angle, side, I'm more than happy to discuss it. And all 3 of those possible ways to do this are correct. Now, in problem 30, again, start with your given. Okay, so I've got problem 1. PT is congruent to RT. Segment PT is congruent to segment RT. QT is congruent to segment ST, and I have a given on that. And once I do that, I'm going to investigate my diagram. And I was like, okay, I'm supposed to prove these two triangles. Let's find them. PQT is this triangle right here. And RST is this triangle. Wow. If I find those two angles, I can use side angle side. And I know those two angles are congruent because of vertical angles. So I'm going to be proving these two triangles congruent because of side angle side. And I'm going to move that out of there because I can't see real well. I've got angle PTQ congruent, I want PTQ, congruent to angle RTS because order matters. Vertical angle theorem. And now I can finish this out and say in step 3 that triangle PQT is congruent to triangle RST because of side angle side congruence. Now in problem 31, we have E is the midpoint. So when I'm investigating E is the midpoint, if I look at E being the midpoint of AD and BC, I know that and that. I just got to state it in my given because of definition of midpoint. I know that this is in a bow tie configuration, so I know that because of vertical angles. So I know the two triangles are congruent because of side angle side. And then after I prove that, I can talk about segment AB being congruent to segment DC because of CPCTC, corresponding parts of congruent triangles are congruent. So I'm just going to get on with this proof and try to get it rolling. So E is a midpoint of segment AD and segment BC. And those are given. In step 2, I know because of definition of midpoint, segment CE is congruent to segment BE, and segment AE is congruent to segment DE. And that is because of definition of segment midpoint. Now, I know vertical angle theorem. I know in step 3, I've got angle AEB is congruent to angle DEC. AEB, DEC, order matters, and I've got my vertical angle in there because of vertical angle theorem. I now have my two triangles congruent. Step 4, I've got triangle ABE congruent to triangle. I went from A to B to E, so DCE. Because it's side angle side. And now my last step, as forecasted, step 5, I know that segment AB is congruent to segment DC because the corresponding parts of congruent triangles are congruent. And that is the 4th of the proofs that were provided in our review for us to write. Now we got some more angle measurement stuff, and I'm using the idea of isosceles triangles. Keep in mind, I got an isosceles triangle. That means this angle and this angle are the same. Okay? So if the measure of angle L is 58, I know the measure of angle J is 58. Okay? And they want LKJ. Well, I got two 58s. Okay, because this is 58, and let me make a big 58 and a big 58, and we'll shrink those down. Let's see if I did that. Well, we'll just make them smaller this way. So I know that that's 58, and I know that that's 58. Those are my 58 degrees. Well, that's 116. So I got 116 so far, and the measure of angle LKJ, that's that big angle, the measure of angle LKJ is 180 adding those together, it's 180. So I got this measure of angle LKJ plus 116. So if I subtract that 116, I get 64. So the measure of angle LKJ is 64 degrees. We'll move that over a little bit so you can see it. So this is 64. Now, what if JL were 5? Now, again, I'm starting over. What if JL was 5? Well, if JL were 5, because of the information that we know, this is an isosceles triangle with an angle bisector. So this is perpendicular, and it's a perpendicular bisector of that side. JL cut in half to be ML is 2.5, half of 5. Now JKM, they're changing our angles again. JKM is 48 degrees. Find the measure of angle J. Well, keep in mind, this is 90 degrees. So this 48 and angle J must make 90 together. So 90 minus 48 gives us a 42. So that'll be 42 degrees. And it's all because that the two acute angles in a right triangle, and remember that half is a right triangle, this is a right triangle right here, and that they said was 48 degrees, so this has to be 42. Now, they're saying that angle J is 55. Okay, so angle J is now 55. What is the measure of JKM? JKM, and for the same reason, 90 minus 55. Okay, that's going to give me a 35. Okay, so now I got JKM as 35 degrees. In problem 36 through 41, I'm just asking you to use this congruent statement and show me the sides that are congruent and the angles, and we're listing them all. So in order, I've got AB, and let me clean that up. I got side AB's in the same position as side CB. Side BD is in the same position as side BD. And my last side, I've got side AD is congruent as side CD. Okay, order matters when we're doing this. Now, because this is kind of crazy here with this, with things being connected, I'm going to do some 3-letter names of angles. I know angle A is congruent to angle C. They're off by themselves and they're in the same order here. But now I'm looking at the picture and I got this one and this one I'm going to talk about next. I've got angle ABD is congruent to angle CBD, and then my last one, my last set, is this angle and this angle, and angle BDA is congruent to angle BDC. So those are the angles and sides I was supposed to find in their corresponding congruent pairs based on my congruent statement that was provided. Now we have 4 problems left. And again, in these 4 problems, let me see if I can paste this back in there. In these 4 problems, I have side, 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 side angle, side congruence, angle, side, angle, 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 side, and HL that I'm running through my head. So I'm going to take my pointer. I got 2 and 2, 3 and 3, 1. So I'm looking like side, angle, side. So I'm saying yes, side, angle, side. Now, when I'm doing this next one, I'm looking at this. I got 1, 1, 1. Uh-oh. Look at that. They're trying to trick us out. Look at that. Right there. Investigating the diagram, not enough information. Let's just do it easier this way. NEI. Not sure what happened there, but we're going to clean this up real quick. Wow, a lot of things just kind of flipped up here, didn't it? Okay, so let's just clean that up, and we'll go NEI. Not enough information, but it's because of this marking right there. That marking and this marking should kind of correspond in this, and they don't. So that's my concern, and I cannot say they're congruent. I just say not enough info. Now in 44, I'm going to bring these back down here. In 44 and 45, let's check that out. I've got my reflexive, and I got the angle, side angle, and angle, side angle. So I'm looking at yes, angle, side angle congruence. And then in 45, boy, it looks like HL. I mean, I've got a right triangle, I got a leg, but I do not have a hypotenuse, and I cannot say they're congruent by HL that way, but I can say they're congruent because all right angles are congruent. So I've got angle, a side, and another angle. So I got yes by angle, side, angle. I hope this helps. If you have follow-up questions, please let me know, and I'll have another short sheet for you to complete, just to make sure that you understand the concepts before the test. Have yourselves a great day.